What if I told you we may have just detected one of the strangest signatures ever produced by a black hole? Not an image, not light, but a vibration in spacetime itself, carrying information from the region around a black hole's event horizon. And this time, scientists were listening very carefully. On January 14, 2025, gravitational wave detectors recorded an extraordinary event known as
the most interesting
GW2. It was what happened immediately afterward. The newly formed black hole began to ring. Imagine striking a bell. The bell doesn't make a random sound. It vibrates in specific patterns determined by its shape. A black hole behaves in a strangely similar way. After two black holes merge, the newborn black hole enters a phase called ringdown. Its gravitational field oscillates at specific frequencies, called quasi-normal modes, and those frequencies contain information about the black hole, its mass, its spin, and potentially, whether the object behaves exactly as Einstein's theory predicts. Scientists extracted these modes from GW250114, and the result was remarkable. The observations were consistent with a Kerr black hole, the theoretical type of black hole predicted by general relativity when it is rotating. And that matters, because black holes are supposed to be remarkably simple objects. Once formed, their observable properties are largely described by just a few numbers, primarily their mass and spin. But here's the deeper question. Is nature really following Einstein's rules, all the way down to the event horizon? This gravitational wave signal gives scientists one of the clearest ways yet to test that idea. And this is where the story becomes fascinating. The event horizon isn't a physical surface. You couldn't land on it. You couldn't touch it. It's a boundary in space-time, beyond which light cannot escape to the outside universe. So when we say scientists are studying a black hole's horizon, we're really talking about measuring the gravitational behavior of the region surrounding that boundary. And gravitational waves may be one of the best messengers nature gives us for doing exactly that. Because if future detections reveal ringdown patterns that don't match Kerr black holes, something fundamental could be wrong with our current understanding. Maybe black holes aren't exactly what general relativity predicts. Maybe quantum effects become important near the horizon. Or perhaps, spacetime itself behaves differently under extreme gravity. We don't have evidence for those possibilities yet, but now, we have a much more powerful experiment for asking the question. For more than a century, Einstein's equations have predicted what black holes should be. Now, we're getting better at listening to them, and the universe is answering, one gravitational wave at a time. Save this video, and share it with someone who wants to understand the strangest places in the universe.